The objective today is to describe how a wireless access point works. And this will be a brief lesson on what a wireless access point is and how to describe its operation. This lesson will also be heavy on review, so I'll go over many concepts you should be pretty familiar with at this point. And just to make sure we are all on the same page with many of the networking concepts we've covered this year. Now, a good way to think of wireless access points, at least in my mind, is like 3D chess. There are a lot of little steps that have to happen to make sure the right person is reading the right binary or reading the right message that was sent for them. So yes, when we're talking about wireless access points, we're talking about how a lot of your phones are able to work, at least when they're connected to something called Wi-Fi. Now, cell towers and cellular communication, man, that's a hard word to say, cellular. That is done in a totally different way, and they have their own protocols, and it's really fascinating. But we won't go into any of that in this lesson. This lesson focused on WAPs, or wireless access points. The first thing we'll do in the lesson, I have a nifty analogy for you to think about, and then we're going to talk about a very, very similar device, being a hub. Then we're going to talk about what's scary about this whole process. We'll talk about how a handshake works, which makes the process less scary, actually. Then I'll give you some resources to read from, and we'll end the lesson by talking about speed and how using wireless affects the speed of your data transmissions. So the way I like to think of a wireless access point is thinking of that traveler from the video game Destiny. That is, this traveler, like the name says, is a single source of light. A wireless access point can be a source for data for internet, but it can be moved around. It can travel around. Wherever it's at, though, it remains the source of connectivity for a lot of people. Every room or office can have its own wireless access point. A lot of times it looks like one of these devices right here. So to give you a better analogy that's a little more on topic, by the way, I think of a hub. So in order to create a wireless network, you need what's called an access point. This is a hub. This is acting like a hub. And you might also think it's like a switch or a router, but without the wires. Notice the emphasis on S. A wireless access point typically just has one wire, or maybe two if we're talking about the power cable. But the wireless access point in my classroom doesn't have a power cable. It gets its power from the Ethernet cable. We've covered that in previous lessons, cable over or power over Ethernet, I mean. And the way that power is carried over those wires is an interesting process, but not on topic today. Your Think Right Share on this page is make an inference. What two character traits, okay? I'm going to say there's two very specific traits that hubs have that wireless access points have as well. So take a quick guess. Pause here if you don't want me to ruin the surprise. And now I'm ruining it. The answer is a hub amplifies the signal. That's what a wireless access point can do as well. And the second thing a hub does is it broadcasts out to all devices. Though not all devices are listening if their name, that is their IP address, isn't called. So more than a modem or a router or a switch, an access point is similar to a hub in that way. So I title this A Rose by Any Other Name. At my house, or maybe at your local Starbucks coffee shop, you'll probably hear these WAPs referred to as just wireless routers. Okay, they do routing, but they're more like a hub. At the end of the day, these wireless networks are usually connected to a wired network, and when choosing between going wireless or wired, you usually should wire up. It's always faster, and especially if you're depending on that connection for intense multiplayer gaming, speed is of the essence, and you don't want any lag or people taking advantage of lag in a game, in a very competitive game. And the reason I say it's usually connected to a wired network is because you could have such a thing like a hotspot that takes in the internet from a cell tower and then spits it out as a wireless frequency for you and other people to use. There's definitely a modem change or a mode change in that process. So I ask here, what's one reason to use a cable to connect And there are reasons why you don't always want to use a cable, so those exist. There's plenty of them actually. The first two that come to my mind is convenience. So if you have a device that you want to move from one end of the room to another, going wireless would be smart. You don't want to unplug and replug every single time you move around if you're moving around a lot. And the second reason might be a smaller reason, but us poor people definitely have to have this reason. It might simply save you money. So instead of buying an Ethernet cable, if you can just connect from Wi-Fi, that's what you're going to go ahead and do. Now the scary thing about this is just the way the thing works. All devices in the room with a network card can read these radio signals that are being sent out. Now essentially, you hear all the data in the room, but you don't necessarily have access to that data. Now here's a very challenging think right share for you. You might have to do a little research on your own, but is this data that's in the air, is it considered a digital data or analog? So those are two terms you definitely should just know by now. So how do we know a person should be able to start the decryption process? Well, that data goes through what's called a handshake. Just like we discussed with TCP in our packets lesson, the wireless access point needs acknowledgement that the data being broadcast was received, and this is part of the handshake process, so it won't have to keep sending that data. It won't just pollute the air maybe with those signals anymore, because once it goes through the RTC/CTS handshake, it knows the device that's supposed to get it has gotten it. Now, before I go more into the security of the decryption process there, let me just say that if you've ever had a hard time connecting this term handshake to computers, just remember this. The point of a handshake used to be to show the person that you come in peace, that you don't have a weapon in your hand. And this is similar to computers in terms of handshakes show both computers that they are the peaceful computers requesting communication with each other. The key here is in your web browser. They are this powerful third party that helps us know the computer we are about to shake with is the one we want. There's a lot of built-in security in the web browser. To learn more about that, you can visit this URL. Here I am, and it says what key exchange mechanism should be used in TLS. Which of these are more cryptographically secure and can be used for securing connection with websites? So if I go down to the answer is always more interesting than the question usually. The person says, you may use a key exchange as part of a Cipher Suite only if the server key, type, and certificate match. To see this in detail, let's have a look at Cipher Suites defined in TOS 1.2 specification. Each Cipher Suite defines the key exchange algorithm as well as the subsequently used symmetric encryption and integrity check algorithms. We concentrate here on the key exchange part. So here's the types. You got RSH, RSA, DH, RSA, DH, DSS, DHE, RSA, and then so on, okay? I'm not going to read all this to you. I just want you to know that the web browser is powerful. The web browser has these options in it. There's always the trade-off between speed and convenience when we're talking about security. And if at the end of the day you spend your time hanging out on information security in the Stack Exchange website, you would be doing yourself good. Lots to learn from that website. So let me go bit by bit through this concept of a handshake and the encryption thing that I brought up, okay? As a refresher, we talked about public key encryption in another lesson in my computer science class. We were talking about a type of handshake when we did that. You may remember a person named Alice accepting a public number from Bob. And there's this mathematical thing that happens. That way, Eve, the eavesdropper, can't read the message between Alice and Bob. It's okay if Eve hears the number because Alice can do some math magic with it. Remember modulo? And after that magic, Alice and Bob will now have a shared private key that they're using to decrypt the message. This idea of trading numbers back and forth, this is the thing that we're calling a handshake. Like I said, it's kind of like chess, right? You have to move a piece and then another piece moves and then you move another piece and somehow we get a very secure communication from the right movements. Now I admit there's a little bit more to it. Here's another website for you to go to. And in our scenario, the the wireless access point, it sends a request to send an RTS and receives a clear to send from the device. So I'm going to request to send you information if I'm the wireless access point, and the computer on the other side is going to send me the clear to send, like you're an okay, I'm ready for you to send that data to the device. Let's check out that Robert Heaton blog real quick. He's talking about HTTPS. He says it's simply your standard HTTP protocol slathered with a generous layer of delicious SSL or TOS encryption goodness. So unless everything or something goes horribly wrong, which it can, this HTTPS prevents people like Eve, the eavesdropper, from viewing or modifying the requests that make up your browsing experience. It's what keeps your passwords, communication, and credit card details safe on the wire between your computer and the servers you want to send this data to. HTTPS is a form of public key encryption. That's a symmetric form of encryption. So you can read much more on the site. I want to point this part out because I like this part. It breaks down the handshake into 3 phases. You have the hello part. So the handshake begins with the client sending a client hello message, right? Like the RTS, CTS thing I just talked about. This hello contains all the information the server needs in order to connect the client via SSL or TOS. And this has all the suites, the Cipher suites that exist, so all the different ways you can encrypt something. Okay, so once a Cipher suite has been agreed on, that is a particular way you encrypt data or a message, there's a certificate exchange process. These CAs are able to prove the client's identity and the server's identity. So now the encryption part, the scrambled up bits comes to the client, and because of the third part of the handshake where there's this key exchange, once those scrambled bits get to the client, that client has the key. Use it to unscramble everything and read the message. And that's funny how very, very fast this handshake occurs in order for that data to seemingly magically appear on your computer almost instantaneously, like right after you click something. You type in wikipedia.com, boom, you're there, even when you messed up and typed in .com instead of .org. It somehow knew the right website, put you right there, and then made sure that there's some security there. HTTPS, you see a little lock bar saying, view the information of the website. Your connection is secure. Certificate is valid. There's 4 cookies being used here. I can go ahead and browse Wikipedia without being afraid I've gone onto somebody else's website and they're going to hijack my browser and start crypto mining from their computer at home. So since we're talking about speed, I am going to go into that in detail here in just a second. But before I do, can you remember what RTS/CTS stood for? I think that's going to be one of my big takeaways I want you to have from everything I just said in the last 10 minutes. When we're talking about wireless access points, there's an average megabits per second. Remember, when we're talking about data transmission, we're using bits, not bytes. Whatever network you're on, be sure to divide your megabits per second of the wireless access point by the number of stations you have on that wireless access point. Now, if you have 20 megabits per second capacity, you got 5 bits, then we are looking at about 5 megabits per second divided by those computers or devices, assuming that they are all, using the internet at the same time. Now, for me to try to understand how wireless access point speed works a little bit better, I had to go to a website called speedguide.net. It says here there are many wireless standards in use today, and newer technologies can bond multiple channels or frequencies together to achieve higher throughput. Now, first, keep in mind that data communication speed is measured in kilobits or megabits. Remember the word bits there. And they have a free bits to bytes conversion calculator there if your mind is very trained on to understanding bytes. I mean, for me, I've memorized your typical HD movie can be 4 megabytes large. But the great thing is, when I'm streaming movies on Netflix, it's not going to transfer the entire movie to me at once. It's going to give me chunk by chunk. I'm going to be able to watch each chunk as it is transmitted. So depending also on the standard that you're using, like 802.11b, you might only be looking at 11 megabits per second. But when we get in these other ranges, man, you can be moving pretty fast. It all depends on your wireless access point. Another thing I should mention that does affect speed is physical distance from the access point, as well as obstructions, so maybe like cubicles or walls or whatever. Check out that word, signal propagation. Extra credit if you could use the word propagation in a sentence correctly. But the last thing that can affect speed would be interference from other wireless networks and devices. That's fascinating to study. So that's the end of the lesson. I want you to think about what character attribute or character trait connects with today's lesson. And then here's your DOL. Pretty simple. Describe how a wireless access point works using 3 specific details. And here's your word bank to help you out. A little bit of extra credit if you could use every single word, I think.